Hi, I'm Dr. Papia Bhattacharjee. So recall in the last video, we are trying to find the critical number for our function r. And we have computed the first partial derivatives of r with respect to p1 and p2. And these are our expression. And you have to set them equal to 0 and then solve for p1 and p2. Now to solve, look at the two equations and look at the second one. I will take this equation first, and then let's see if I can simplify this a little bit. So if you take out a common factor of 3, you get negative p2 plus p1 plus 500. That is equal to 0. So you can get rid of this 3, you can divide both sides, and then we'll have negative p2 plus p1 plus 500, that will be 0. And then if you take p2 on the right hand side, you can write now p2 in terms of p1. So p2 is p1 plus 500. So now we can take this expression for p2, put it in the first equation, and we'll just have an equation in p1, and we can solve for p1. So let's do that. So let's take this one and plug it in the first equation. And the first equation is, so negative 4 p1 plus 3, now instead of p2 I'm writing this p1 plus 500 and then plus 1000. That is equal to 0. Okay. So we can distribute 3, so it will be 3 p1 plus 1500 plus 1000 is 0. So negative 4 plus 3 is negative 1. So you get negative p1 plus 1500 and 1000, so 2500. That is equal to 0, and you see that p1 is 2500, right? So let's go up here. So we get our p1 is 2500. And then you can plug in the value of p1 to get p2. So p2 will be 2500 plus 500. So that is 3000. Recall that p1 and p2, their prices per unit, and so they are both dollars. Okay, so this is our critical number, 2500 for p1 and 3000 for p2. Now the question is whether this critical number is where the function will have a max or a mean. Okay, so how do we test using the second partial? So we already have the first partial derivatives. Now all we need to do is compute. So take the first partial derivative and let's compute the partial with respect to p1 of the first partial derivative with respect to p1. Okay. So let's look here. There are 3 terms. Okay, and the first term has p1. The derivative is negative 4. The derivative of the second term is 0, third term is 0 because they are both constants. All right. Next, compute partial with respect to p2 of the first partial derivative with respect to p2. And look, the first term has p2, so its derivative is negative 3. Second term will be 0, third term will be 0 as well. And then finally, we need to compute the partial with respect to p2 of p1. Okay, so the first expression, but with respect to p2. Okay, now since this is with respect to p2, the first term is a constant, so the derivative is 0, and you will have derivative of second term is 3, third term is 0 as well. And recall that using these, we have to compute a quantity D. So D is the product of these two. So -4 times -3, and then minus 3 square. So this is equal to 12 minus 9. And so this is 3, which means D is positive. Positive at the critical number, right? And we know this, we know that the second partial is -4, so this is negative. And recall the second partial test. If D is positive and this guy is negative, that means it's a max. So we have a maximum at the point 2500, 3000. And so we can conclude that our revenue, R, is maximum for price P1 is $2,500 per unit, and P2 is $3,000 per unit. So that concludes this problem. Thank you.